Good morning or good afternoon, as the case may be. My name is Sosale Mohana. I'm a maths teacher who has taught maths for over 50 years in 3 continents and 3 countries, like India, in Asia, Kenya in Africa, and England in Europe. I've just retired a couple of years ago, and I thought I should use my experience to record and deliver a number of lessons based on the British curriculum for A-level maths, so the students who want to reinforce their learning can use it. I have a master's in maths, of course, way back in 1969. I completed my master's in maths, and then I did my teacher training in 1974. I've been working since 1969 till 2019, clear 50 years. So I hope these lessons are useful to you, and you're welcome to watch them, and then with each lesson, there will always be a document which covers whatever has been done in the lesson, so you could use that perhaps as your own notes, or maybe to go over what has been taught during the lesson. I hope you enjoy the lesson. Hello. I purposely did not rub off the topic heading and the information I had put last time, because this is a continuation of the story from where I stopped in the previous lesson about the history of quadratic. Remember, I talked about the article from the 2 professors. All this is based on what I read from there. And we had stopped at square root of 2 being first proved by Hippasus of Metapontum. Metapontum must be a particular place, and he is from that place. So he was known as, like I'm Mohana from Sosale. Anyway, something like that. So, and he had proved that root 2 is irrational. But that, how did they do it? Because where did that come from? That came from the mathematician's interest in Pythagoras' theorem. Because if this was x, that was x. Or this was 1, that was 1. By Pythagoras' theorem, the area, that one was root 2. Now, what is this root 2? That's where it all started, and he proved it's irrational. It's somewhere between 1.414 and 1.415, 1.4142, blah, blah, blah. What has that got to do with the A0, A1, A2, A3, A4 sizes we have? To understand that, let's remember I told you the A0 paper is 1 meter square. Okay? Keep that in mind. So now, let's look at this. This is, let's assume the A0 paper, the width is x, y, and the length is x. So the area is xy, and then width over length is y over x. Remember I taught you last time, what you do is, you cut this off halfway. So in other words, you got now, that portion is gone, you're left with, so what is the ratio of width over length? Remember, the width is now x over 2 over the length is y, which is x over 2y. And I also made a claim very clearly that this particular thing, of course you need to make it as a portrait because the width has to be less than the length. And then the original A0 and A1, they must be similar. A0 and A2, A0, A1, A2, A3, A4 must have the same ratio. Okay? So therefore, y over x must be equal to x over 2y. What do we get from there? I get x squared equal to 2y squared, which gives you x equal to y root 2, or y equal to x over root 2. Agreed? Now, let's go back. So do you understand how I got that ratio? I'm only interested in that ratio because if I go back, let's look at the A0 paper. A0 paper, I assumed the area was 1 meter squared, that was y, that was x, area was xy, but from the ratios, I got y equal to x over root 2, which is x squared over root 2. But that area is 1 meter square, so therefore, x squared equals root 2 meter square, x equal to square root of 2 meter square. Will become meter because you take a square root, meter square becomes meter. Now is where it becomes interesting. What is square root of 2? If you were to use a calculator, use it if you want to. Let me use mine. Square root of 2. I need my glasses, obviously. I can't read without it. Sometimes, of course, I forget and I struggle to read only to realize I didn't wear my glasses. Square root of 2. Right. Square root of bracket, square root of 2, close bracket, close bracket. 1.1892. Very interesting. That's 1.1892 meters. To convert it into millimeters, you must multiply by 1,000. 1189.2 millimeters. 0.2 millimeters is so small, 1189 millimeters. Now, do you see the link? Let's go back to your A0. And if you find that the width will be 841 millimeters. Yeah? So therefore, an A0 paper actually has a length of square root of 2 millimeters. This was done somewhere in the 1850s based on area of a rectangle, based on similar figures, which goes back to, unfortunately, not any rectangle, a rectangle whose length is square root of 2. And that square root of 2 goes back to the time of Pythagoras when they found root 2. In fact, x squared equal to root 2, the very first quadratic equation, which was a challenge to mathematicians way back in 350 BC. Now, let's see. So, therefore, if I were to do the ratio, now I'm going back to the ratio. If you do the ratio 11/8 length divided by width, reverse of what I did here, I would get, I've done it because I didn't want to, it's 1.4137. So let me rub this off and write it here because it's going to the corner there. So if I were to do length over width for A0, the ratio would be 1.4137. And if I were to do for A1, length divided by width is 1.4158. I've used a calculator to figure out. And if I do for A2, it is 1.41428. 43 I can say. And if I do for A3, it's 1.4141. And if I do for A4, it's 1.414. Now, what is this 1.414? All the values are leading to 1. As you go, become smaller and smaller and smaller, the ratio is approaching a limiting value. So, if you take up any of your standard paper sizes, A0, A1, A2, A3, A4, A5, A6, measure the width, measure the length, divide. If it has been properly manufactured, it should be around square root of 2 because all the ratios lead to square root of 2, which was discovered roughly 350 BC. So you might be using an A4 paper today, but the logic behind the size of an A4 paper goes back to 350 BC. And the logic, and the first time we discovered this as a standard size uniformly accepted everywhere was around 1840s from France. Till then the papers used to be odd sizes. Someone would make that big, someone would make that small. In fact, it would be this small, some people, depending upon, whereas these were the standard sizes accepted universally. Today, when you look at an A4 size and an A2 size or an A3 size paper, they conform to these dimensions. So quadratic equation x squared equal to 2 has come and joined this. That's interesting. But then, they have been harping on only one quadratic equation. Square root of 2, square root of 2 and square root of 2 and nothing else. So what? That was fluke. So you just had square root of 2. So why are we harping on it? No. There is something more interesting which I will have to take up perhaps in the next lesson, because I'm going to link this. Take another example how quadratic equations have played an important role in our lives. So that we'll talk of in the next lesson. Thank you very much. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.